Let's take a look at the quadratic formula. With our quadratic formula, a problem has to be of this form. ax squared plus bx plus c equals 0. Quadratic. You can have any variable, it doesn't have to be x's. A, b, and c represent numbers. Typically integers, but they don't have to be integers. Now if you got in that form, the quadratic formula says your answer is going to be x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And let's take a look at a problem. Our first one here, we have 21x squared plus x minus 2 is equal to 0. And it says solve it using the quadratic formula. Well, it's in the right form because we have 0 on this side and it's a quadratic. So first thing we got to do is identify our a, b, and c. A is whatever number's in front of your x squared, which is 21. B is whatever number's in front of your x, which is 1. And c is your number at the end, which is a negative 2. Now, unless you don't mess up on signs, it's a good idea to go through and replace all of your variables with sets of parentheses before you plug in your numbers. So we're going to have x is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2a. And now we'll plug in what we identified. We said a was 21, so everywhere we had an a, we'll put in 21. We said b was 1, so everywhere we have a b, we'll put in 1. And we said c was negative 2, so everywhere we have a c, we'll put in negative 2. And now you want to simplify. So we got negative 1 plus or minus square root. 1 squared is 1. Negative 4 times 21 gives us 84 times, negative times positive is negative times another negative is positive. So 84 times 2 gives us 168. So we got 1 plus 168 over 2 times 21 is 42. So we got negative 1 plus or minus 1 plus 168 is 169 all over 42. And you should always simplify your radicals before you go on. 169, that's 13 times 13. Remember with square roots we're looking for pairs of something, so here's a pair of 13s. A pair of 13s is going to come out in front as a single 13. So we got negative 1 plus or minus 13 over 42. Now, if your radical disappears, then it's a good idea for you to split them up into two separate pieces. We're going to have a positive version, we'll have a negative version. What that plus or minus means is we'll have negative 1 plus 13 over 42, and we'll have negative 1 minus 13 over 42. And again, it's beneficial to split it up like this if your radical has disappeared. Well, negative 1 plus 13 is 12. So we got 12 over 42. And that simplifies. 12 and 42 both divisible by 6. So 12 divided by 2 is, or 12 divided by 6 is 2. And 42 divided by 6 is 7. So that gives us 2 7s. Negative 1, negative 13 is negative 14 over 42. And I believe these are both divisible by 14. Just from past semesters. Typically I just see the 7, but I think it's more than that. But let's do the 7, just because I'm not sure. Negative 14 divided by 7 is negative 2. 42 divided by 7 is 6. And I see it does reduce some more. So that gives us negative 1/3. So those would be your two answers for that problem. Let me start a new page here. And let's look at our second example. So we got x plus 1 over x is equal to 5. This is not in the right form. It's not a quadratic. We don't have an x squared. Well, if we think about our test for solving any kind of equation, almost our first step we do is get rid of fractions. And you do that always the same way. You multiply everything by the LCM of all your denominators. Now we only have one denominator, the x, so we're going to multiply everything by x. So I'll take x times x. I'll take x times 1 over x. And x times 5. X times x is x squared. Those x's cancel, so we got plus 1 equals 5x. Now this is starting to look closer. This is looks like quadratic. So let's get everything over one side, 0 on the other. So I'll take the 5x to the left side, and we got x squared minus 5x plus 1 equal to 0. And now it's in the right form. It's quadratic, and we got 0 on one side. Let's identify our a, b, and c. A is whatever number's in front of your x squared, which is 1. B is whatever number's in front of your x, which is negative 5. And C is your number at the end, which is 1. Our quadratic formula. We're going to have negative b plus or minus square root of b squared minus 4 times a times c all over 2a. And put little letters underneath there. Negative b plus or minus b squared minus 4ac all over 2a. Okay, well, we said a was 1, so everywhere we had an a, we'll put in 1. We said b was negative 5, so everywhere we have b, we'll put in negative 5. And we said c was 1, so wherever we have a c, we'll put in 1. Well, negative negative gives us a positive 5, plus or minus. Negative 5 squared is 25, minus 4 times 1 is 4, all over 2. Which gives us 5 plus or minus 25 minus 4 is 21 over 2. And that's our answer. Now we don't try to split this up into a positive version and negative version because the radical didn't disappear. So it wouldn't benefit us to split it up. Sometimes you'll split it up because you have an imaginary part, but that's a different case. Let's take a look at this one. So we got 7w squared is equal to negative 2w plus 3. Now this is a quadratic. It's a different variable. It's not x, but same idea. This is a quadratic, so we don't get everything over one side, 0 on the other. So I'm going to have 7w squared. Take negative 2w over, becomes a positive 2w. Take 3 over, becomes a negative 3. Equals 0. Again, it's quadratic. We got 0 on one side, so now we can start in with our formula. A is whatever's in front of your w squared, which is 7. B is whatever's in front of your w, which is 2. And C is your number at the end, which is negative 3. Our formula says x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. Label that's b, and this is b, a, c, all over 2a. Okay, we said a was 7, so everywhere we had an a, we'll put in 7. Said b was 2, so everywhere we had b, we'll put in 2. And c was negative 3. So I got negative 2 plus or minus. 2 squared is 4. Negative 4 times 7 is negative 28 times a negative 3. I don't know what it is yet, but it's positive. 4 times 7 is 28 times 3. 4 to 84. Over 14. Okay, so that gives us negative 2 plus or minus square root of 88 over 14. Now, always you should simplify a radical before you go on, and that's what we'll do here. So we got negative 2 plus or minus square root 88. That's 2, 4, 8 times 11 all over 14. Now remember, we're looking for pairs of something. Here's a pair of 2s, so this pair of 2s is going to come out in front as a single 2. So we got negative 2 plus or minus 2 square root. And we're left with a 2 and 11 inside. And you can only bring something out if it's a pair. We don't got a pair of 2s or 11s, so we just multiply these together. 2 times 11 is 22 over 14. Now this is something that pops up fairly often in the quadratic formula. If you can divide this number, and this number by the same number, do so. And those are all divisible by 2. So we're going to get negative 1 plus or minus 1 square root of 22 over 7. Now notice I do not touch what's inside the radical at all. I just touch those three numbers. So that's going to give us negative 1 plus or minus square root of 22 over 7. Again, I do not split that up into two separate pieces because the radical didn't disappear. Let's take a look at this one. We got 3x squared minus 5x plus 9 equal to 0. It's already a quadratic, has 0 on one side, so it's already in the right form. So let's just identify our a, b, and c. A is whatever number is in front of your x squared, which is 3. B is whatever number is in front of your x, which is negative 5. And C is your number at the end, which is 9. So we're going to have x is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Let me label these. This is b, B, A, C, and A. Okay, we said A was 3, so everywhere we had an A, we'll put in 3. We said B was negative 5, so everywhere we have a B, we'll put in negative 5. And we said C was 9, so everywhere we had a C, we'll put in 9. Negative negative gives us a positive, so we got positive 5 plus or minus square root. Negative 5 squared is 25 minus 4 times 3 is 12 times 9 gives us 108. Let's see if that's right. Okay, 8, 1. Yeah, that's right. All over 2 times 3, which is 6. Okay, so now we want to subtract those. I think negative 83. Let me double check myself. 3, okay, yeah, negative 83. Now remember, if you have a negative inside of your square root, that's going to come out as an I. So this becomes 5 plus or minus I square root of 83. And I don't think 83 breaks down any. Looks prime anyway. Now whenever you have an I appear in your problem, this is where you want to split it apart. You want your real part separate from your imaginary part. So put the 5 over 6 plus or minus square root of 83 over 6 with an I to the side. And that'd be your answer. And that's our quadratic formula.